Good day everyone. Today we are presenting our project. The title is Simulations of Bit Rate Error BER and Signal to Noise Ratio SNR for the modulation scheme of BPSK and QPSK under the AWGNs and LING fading channels. So first, let me introduce our group members. Okay, my name is Chiou and then we have ELAINE and FLOYD. Okay, for the introductions. In the recent times for the fast-growing wireless technology, digital modulation schemes contribute to the evolutions of communication, which provide more information carrying capacity, better quality communications, data securities, and others. So for the bit error rate is the main parameters of the digital communication system. So what is bit error rate? The bit error rate is the numbers of the rate at which the error occur in the transmissions. So for the performance of the channels, it can be evaluated from the BER and the SNR ratio curve. So in communications, the channel's performance is dependent on the noise. So the main reason for the degradations of the data channels and the corresponding bit error rates is noise and change to the propagation part where the signal part are used. So we are mainly focusing on the two types of modelings, channel modelings, which are adaptive white Gaussian noise, AWGN, and relaying fading modes. So for the AWGNs, the AWGN is the model that does not account for the phenomena fadings, the frequency sensitivity, interference, or nonlinearity. So what is the relaying fading channels? So in this case, for the relaying fading channel, which is not line or side component present, because of the obstacle and the reflection presents, the transmitting channel, the transmitted signal arrive at the receiver over the multipath. So for the objective of our project, first is to simulate the bit error rates performance of the PSK, phase shift keying modulation scheme of BPSK and QPSK over the AWGNs and the LING fading channel. So for the second objective is to study the relationship between the bit rate error and the signal to noise ratio in the modulation scheme. So for the last objective is to construct the MATLAB simulations of the both modulation scheme. For the problem statements, in today's developing world, we use the digital signal to transmit data. They have a lot of the advantage of using the digital modulations over the analog modulations, such as greater security to our informations, and more immunity to noise and others. So during the analog to the digital signal conversions, there are some losses of informations in the quantization process. So by adding the error control codings, it may reduce the bandwidth efficiency but increase the power efficiency. So in the M-array schemes, by increase the bandwidth efficiency, it may require the higher power transmission to keep the same of the bit error rate. So the other factors such as the cost and the complexities of the receiver in the wireless networks. This is what the engineer will concern about. So at here, we will determine the bit error rate performance of the PSK modulation scheme of the BPSK and QPSK over the AWGNs and the LING fading channels to figure out which modulation scheme is better. So for the methodology, as we all know that the bit error rate is the number of bits with error divided by the total number of bits that have been received or transmitted. So in theoretical, the BER for the BPSK and QPSK modulation scheme over the AWGN is 1/2 error functions of the square root of EB over N naught. But for the bit error rates of BPSK and QPSK's modulation scheme over the LING fading channel with the white Gaussian noise is given by 1 over 2 bracket 1 minus square roots of EB over N naught over 1 plus EB over N naught, where the EB is the energy per bit and the N naught is a noise power spectrum density. So both these three formula we are using for simulates our MATLAB codings. Okay, for the block diagrams, this is a block diagram that we are using to simulate our MATLAB. So first we have the input data signal that will pass through the modulator, the BPSK modulator, and then will pass through the channel. So here we are using two channels. One is AWGN, and then the other one is LING fading channel, and then it will receive by the demodulator. After that, we will try to calculate. We will calculate the error rate. So for the QPSK also the same. So the first input data, and then we will pass through the QPSK modulator, and then we'll pass through the channel, and then we'll receive by the demodulator, and then it will calculate the error rate. So next, for the MATLAB coding, I will pass to ELAINE.
Here show the MATLAB coding of BPSK modulation in AWGN channel and Rayleigh channels. First, we set the frame length and range of SNR that we wish to simulate, and we initialize some variables. Then we generate some random bit from this formula. This shows the formula of BPSK modulator and noise variance. To calculate the Rayleigh channel fading random variable, we are using this formula. And then we send the result of Rayleigh channel fadings and BPSK modulator over Gaussian links to the receiver. Then we have some BPSK demodulator at the receiver. The formula here shows to calculate the bit error. Then we calculate the bit error rates based on the value we calculated before. Here shows how we plot the graph. We plot a simulated BER and theoretical BER in Rayleigh channel, and a theoretical BER in AWGN channel. This shows the result after running the BPSK modulation coding. Next, here is the QPSK modulation coding in AWGN channel and Rayleigh channel. We're using almost the same concept to simulate we use another formula of QPSK to calculate the SNR, and we split the stream into two streams for quadrature carrier, and the modulator formula is also different from BPSK. The formula used to calculate the Rayleigh channel fadings, random variables, noise variance is the same as BPSK modulator. Here shows the formula to calculate the variable to send over Gaussian links to the receiver. The QPSK demodulator at the receiver also different. Then the formula to calculate the bit error and bit error is the same as BPSK modulations. Here we plot the simulations BPR codings and BPR theoretical. In Rayleigh channel, we're using the same formula. The BER theoretical in AWGN also using the same formula. These both formula can obtain from probability of errors. Here shows the simulated result of QPSK modulations. Next, I pass to FLOYD to explain about the discussion and conclusions.
Comparing both channels' resistance to error in this graph, it shows that the Rayleigh channel, the signal is more prone to errors. Also, the amount of energy required for transmission over AWGN channel is lesser than the energy required for transmission over Rayleigh channel. The BER for transmission over AWGN channel is also lesser than that for Rayleigh channel. From the table, it shows that the BER of QPSK is higher than the BER of BPSK in both AWGN and the Rayleigh fading channel. This is because both the modulation schemes are compared with the same bandwidth. Since the data rate of QPSK is twice of BPSK, it will lead to a higher BER. In conclusion, after simulating the bit error rate of BPSK and QPSK over AWGN and Rayleigh fading channel using MATLAB, we have deduced that BER decreases as the SNR increases. From the figures obtained on bit error rate, it is decided that BPSK is the more effective modulation scheme compared to QPSK. Thank you and have a good day.